Hi, this is our recent work on Bayesian weak supervision via an optimal transport approach. I'm Putra Manggala, and this is joint work with Holger and Eric Nalisnick. A bit of background, weak supervision has been increasingly popular for annotating unlabeled data. This is useful for building large-scale machine learning models. One example is crowdsourcing for annotations via Amazon Mechanical Turk. So here we can enlist help from humans to annotate datasets. Another example is data programming, where weak labels are generated programmatically by having humans produce labeling functions instead of the labels themselves. This allows the labeling process to scale to large sets of unlabeled data. Now, the labels produced in weak supervision are typically noisy, so multiple sources can provide labels for a data point, and they might be conflicting. Here's an example. Consider two human labelers, blue and purple, with three weak sources, depicted by the blue and purple cylinders. The blue labeler produces two distinct labeling functions, so two cylinders for the blue labeler. The weak sources contain the weak labels, the y tildes. As you can see, each data point may be labeled multiple times across the weak sources. For example, data point 1 is labeled by weak source 1 and 3. So y tilde 1 at the top and y tilde 1 at the bottom. The main research question here is to develop a mechanism for aggregating these weak labels to estimate the latent true label y's depicted by the black cylinder. In this work, we propose an optimal transport-based generative model to predict the true labels. In short, we'd like to infer a transport cost matrix random variable per source, CL, and we use optimal transport to connect the true latent label yi to their observable weak labels y tilde li's. We use a fully Bayesian treatment with a tractable subroutine called sinkhorn scaling. We saw an improved accuracy for downstream models trained using our latent label estimates. And there's more in the paper, so I hope to see you at the poster. Thanks.